Hey everybody, I'm taking a look right now at assignment 64 in class. It says relating f, f prime, and f double prime fill-ins. Should be a hyphen there. Fill-ins test review. I know we did one of these recently, but guess what? You need to do this again. These are different questions though, so don't worry. So number one says, and you should have this open while we do it. In fact, why don't you go try this one now? Go get that worksheet out of our team. Open it up. It's the fill-ins one. Give it a try. I mean, it really should go pretty fast for you, especially the front side. Back side, we might need to think a little bit. Well, there is no back side. Never mind. What was I looking at? That's very strange. Could have sworn there was this whole other part to it. Hold on a second while I go back and look some more. Oh, that's on that worksheet. Okay, yeah, really, this should go pretty fast for you. So go fill it in, come back in 5 minutes, 10 minutes, and we'll take a look at the answers. Okay, number one, f is concave down, then f prime is decreasing. Decreasing. 2. If f is decreasing, then f prime is negative. 3. F prime is decreasing. Well, when f prime is decreasing, I know that f double prime is negative, and therefore f is concave down. So what do we have here? F prime is decreasing, then f double prime is negative. Okay, and you could certainly write f double prime is less than 0. But they give us that line, and it says f double prime is. And so if I'm looking for something to put there, I'm putting negative. All right. 4. 4 says if f is increasing, then f prime is positive. 5. If f double prime is less than 0, f double prime is less than 0, that means that f is concave down. 6. If f prime is increasing, not f increasing. If f was increasing, then f prime would be positive. This is f prime increasing, which means that f double prime is going to be positive, and since f double prime is positive, f is concave up. 7. If f double prime is greater than 0, then f prime is doing what? Well, f double prime represents the slopes of f prime, and if f double prime is positive, then the slopes of f prime are positive, which means f prime is increasing. 8. F prime of a equals 0, and f double prime is concave up. Concave up, f prime equals 0 at x equals a. So then f has a minimum at x equals a. This was our second derivative test, using the second derivative and the first derivative to help us find maxes and mins. Whenever f is concave up and f prime is equal to 0, that's going to be a min. If f is concave down and f prime is equal to 0, that's going to be a max. Right. 9. 9 says if f is concave up, then f double prime is positive. 10. If f prime is increasing, then f double prime is positive. That was 10. How about 11? 11 says if the slope of f prime is negative. Now, think about that. The slope of f prime. The slope of f prime is called f double prime. And they're saying here in problem 11 that the slope of f prime, or f double prime, is negative. So if f double prime is negative, then f double prime is negative. Okay. 12. There is a minimum at x equals a when f prime of a has a, oh, sorry, I skipped. No, we're doing 12. There is a minimum at x equals a when f double prime of a is greater than 0. Remember, that's that second derivative test. I want concave up to have a minimum when the slope on f is 0. So what are we doing here? And f prime of a is 0. And f prime of a equals 0. So that's the first fill-in, and that's the second fill-in on number 12. Number 13. Number 13 says f double prime greater than 0, then f prime is doing what? These are the slopes of this graph. If the slopes of this graph are positive, that means this graph is increasing. 14. F prime of a is 0. F has a what at x equals a? Well, many students want to write min or max here. And I'm sorry, that's not correct. Does there's a 0 slope on y equals x to the third. Just because f prime is positive, is 0 at that point, does that mean I have a max or a min at that point? No. If I look at an f prime sign chart, and I know that I have a 0 here, what if I have positive, positive? There's no sign change there. There's no max there. What if I had negative, negative? No, there's no min there. A minimum on f at a would be negative to positive. This is negative to negative. So just because I know the slope of f is 0 at a, just because I know there's this point on f prime, I can't say anything about maxes and mins unless I know what's happening to either side. And in this question, I don't know. So what is it that I'm supposed to write? F has a horizontal tangent. That's all I can say. All I can say, because f prime equals 0, is that the slope on f at a is 0. Horizontal tangent has a slope of 0. Okay, 15. 15 says if f has a corner at x equals a, then f prime is undefined. So, we have a corner. Wah, zoink. And don't say corner, or don't you need some calculus. This is a fill-in, so undefined is plenty. But when this shows up in free response, then you gotta say the limit as x approaches a from the positive side of f prime does not equal the limit as x approaches a from the negative side of f prime. The limit of the slopes from over here, the limit of the slopes from over here, they're not equal, so there's no derivative possible there. Because remember, derivative f prime is the limit as x approaches 0 of f of x minus f of x approaches a, f of a over x minus a. The derivative is a limit. And if that limit isn't the same from both sides of x equals a, then that limit can't exist. Okay, that was 15. 16. 16 says if f double prime is greater than 0, then we know that f prime is increasing. 20. What's 20 doing there? I guess I ran out of space and I just sort of packed it in. So this was 16. Let's take a look at 17 and come back to 20. If f double prime is greater than 0, then what's f doing? F is concave up. 18. There is a max or min at x equals a when f prime is 0 or undefined. You get 2 underlines for those. when f prime is 0 or undefined, and when there is a blank blank on f of x at x equals a. And so blank blank, we want sign change. We need to go from positive to negative or negative to positive in order for there to be a min or a max on f at a. Okay, 19. Ooh, 19 is the last one. When f prime of a equals 0 and f double prime of a is less than 0, then we're looking at this situation. Here's our x equals a, and I'm looking at a max. F prime of a, not f prime, sorry, the question says f of a has a max at x equals a. Okay, well, there you go, 64 in class, pretty fast, and we need to be comfortable with those things.